And we have talked about.
This is like the first time you've heard us talk
It's usually
during your lesson.
Okay, so we've talked about the graph a little bit.
Trying to do my work.
We've talked about taking the function and finding the zeros. And so now we're going to put it all together. How do I use all the characteristics of the graph and the function itself to draw a picture of the graph? Now today we're not going to get into the graphing piece too much. We're really just going to talk a little bit more about zeros. And then tomorrow we'll actually start the graphing piece. What we need to look at today, everything I've shown you so far, the zeros were real numbers, but they don't have to be. You could have imaginary zeros. We know that comes up when we do the quadratic formula. Sometimes we get an imaginary number. And so there is something called the conjugate zeros theorem. And what it says is in a polynomial with real coefficients, if a plus bi is a zero, so is the conjugate. Remember, conjugate, all you do is change the sign on the imaginary part.
Does that make sense?
So, if you are looking at a polynomial, and that polynomial we're assuming all real coefficients, so that means the original polynomial, there are no i's in it. It's just a standard polynomial. The imaginary zeros come in pairs. And this kind of makes sense because you have to think, what's I times I, or I squared equal to? -1. So in order to cancel out an I, you have to have two of them. So that will always be the case. If we know that one imaginary number is a zero, its conjugate is automatically.
Yeah, I got it.
Let's look at a problem. I want to find a polynomial that meets these requirements. So my zeros are 3 and 4 plus I. I only gave you 2 zeros. However, if 4 plus I is a 0, what else has to be? 4 minus I. So I'm going to just go ahead and add that to my list. So even though I only told you 2, I know there's really 3 of them. Now this is only true for imaginary numbers, so -3 does not have to be a 0. All right, so my polynomial, I'm just going to call it P of x. To get your factor, you do x minus your 0, right? So if 3 is a 0, then we would have x minus 3. If 4 plus I is a 0, so you have to do x minus the 4 plus I. So what does that turn into? If 4 minus I is a 0. And so I have my polynomial from that.
Are we ever going to find an original problem?
I will not make you multiply it out. It's going to leave your polynomial in factor form. All right. So let's take a look at B. My zeros are -2, positive 5i, and -1 minus I. So what else has to be a 0? -1 plus I, or sorry, -1 plus I and -5i both have to be. Because we had 2 imaginary zeros, so I need the conjugate of each of those. So how many parentheses am I going to have here? 5. It does not matter what order you write those parentheses in. You just have to have them all. So if -2 is a 0, what would my factor be?
X plus 2.
If 5i is a 0, if -5i
X
is,
plus 4.
okay, for -1 minus I, what will that give me?
X plus 1 minus I.
Think about like x minus the -1 minus I.
So it's plus I. Plus I.
So it'd be x plus 1 plus I. Last one, if I do x minus -1 plus I, that gives
X minus 1 minus
X plus 1 minus I.
I. Oh,
So the only difference on those is the sign on the I.
Because conjugate.
All right, so far so good?
Yes.
All right, so the next one, I'm going to add a different requirement in here.
Oh. Oh.
So I want a polynomial of degree 3. Gage, you with me?
I'm already done.
Oh, great.
That's just 3.
Feel free to teach us.
There you go.
So if the degree is 3, how many parentheses would I expect?
4.
4. 3.
2.
2.
Oopsie.
1.
3. The degree is the same as the highest power of x.
I was thinking turning points.
So we should have an x cubed.
Oh,
Okay. So if -3 is a 0, what would be in my parentheses?
X plus 2.
If -2 is a 0,
X plus 2.
if 5 is a 0.
X minus
Okay. None of those are imaginary, so I don't have any conjugates. Can I even have any more x's in this problem?
1. No.
No, because I said degree 3 and this is already degree 3. But I gave you another requirement that we haven't seen before. I told you f of -1 equals 6. What does that mean?
You need to plug in -1 for X.
When x is -1, this whole thing has to equal 6. Now the only difference I could have in my problem is I could have a coefficient out in front. I could be multiplying all this by 2 or 6 or something like that. Okay, so what I'm going to do is plug in my -1 and figure out what this number out in front would have to be. What would my coefficient need to be to make this true? So, -1 plus 3, -1 plus 2,
1.
-1 minus 5,
-6.
and this whole thing has to equal 6. This tells me -12a equals 6, so a is,
-1/2.
so my actual polynomial is -1/2 times x plus 3, x plus 2, x minus 5.
Show you that somewhere.
Oh!
Oh, I'll get right on that.
So I might just.
Okay, what about this one?
Multiply multiplicity 3, that's the same as
Can't go with
Well, what does the multiplicity tell you?
Oh, it bounds or cross.
In terms of the graph, it tells us if it bounces or goes through. How would I write that? If 4 is a 0, we know we have to have what in here?
4x is.
X minus 4.
When I told you the multiplicity is 3,
That means that's to the 3rd power.
it's to the 3rd power.
I said that. I said it's to the...
No, you lying. That's
Oh,
not. You
It's
did
not
say that.
necessarily the degree if I put more zeros in there, but I get what you're saying. It's the exponent
You did not
on
say
that
that.
term. Okay, then I also know f of 2 has to equal negative 24. So that's telling me there might be a number out in front. Let's figure out what that number is. If I put in a 2, 2 minus 4
Negative 2.
cubed, and this has to equal negative 24.
That means it's a 3.
So I get negative 8a equals negative 24. So the a is 3.
Cool, skinny.
So that's 3 times x minus 4 cubed.
Do we have to write that?
Yes.
I know, but wouldn't A equals 3 be the answer too?
Well, I mean, if you wanted to go back and erase this a and put a 3 there, I don't care.
Wake up. What's the real today is? It's Wednesday.
Hump day.
National Wednesday.
National Wednesday?
That's not criminal.
Today was struggle day.
You
at my
never seen
house.
it before?
I think all my kids were crying this morning when they got to
Cedric.
It was rough.
I woke up at 7.
Ooh, I played a cramp. He like,
She called me 13 times. And I had 10 alarms set.
So today was a struggle for everybody across the board.
Yesterday I woke up at 7:15.
Like he's not
15.
I got apple juice on.
Also,
So, I have given you problems before. We had one, like the last question on our quiz yesterday, where I gave you a polynomial and I gave you the first 0. And I asked you to find the rest of them. Okay, so this one, we're doing the same thing. I said find all complex zeros. So that just means it could be real, it could be imaginary. We don't know, we have to find them.
This guy.
Of this polynomial, if 3i is a 0.
We have to do synthetic division with a
Synthetic division with 3i. Okay, when you do this, leave yourself a little extra space. When you put your coefficients, you're going to want to space those out a little more than you're used to.
Oh.
no.
one. He's already finna suck back at this toe. Look how this is going.
Okay, are we ready?
No.
So, first coefficient comes down. 1 times 3i. Okay, can you add negative 1 plus 3i?
No.
Oh my goodness.
So we have those two terms.
Oh.
Alright, now we have
terms up.
to multiply.
that.
So I have to take 3i times my negative 1 plus 3i.
When we get rid of our I.
So 3i times negative 1 is negative
No,
3i.
we don't.
3i times 3i is 9i squared, which is
Nine.
negative 9.
Yeah.
Wait, that's not proper form though.
I'll switch it around in a second. So, adding like terms. I can do the 10 plus negative 9, that's a 1. And I still have this minus 3i. So now we're back to multiply. So I have to take 3i times 1 minus 3i.
Why do they feel like they needed to create this?
So 1 times 3i is 3i. 3i times negative 3i is, negative 9i squared, which is positive 9. The 9's cancel, so I just get a 3i.
We get rid of our thing.
3i times 3i
Negative 9.
is 9i squared, or negative 9, and we get a 0.
Oh, what is wrong?
Okay,
Oh.
that was the ugly stuff. Everything from here on out is going to get much nicer. Now, we don't really want to try to attempt any slip and slide or anything with imaginary coefficients. That would be a mess. But if 3i is a 0, what do you know? Negative 3i is also a 0. So what we are going to do, listen carefully here. Because negative 3i is also a 0, I am going to do synthetic division again with negative 3i and the answer I just got out.
No way, bro.
Okay?
So.
So,
We have to go to the next.
this was my remainder. Guys, I'm not going to talk over you the whole time. This is my remainder. We need just the coefficient piece. So I'm going to put the 1, negative 1 plus 3i, 1 minus 3i, and 3i. In this step, all of my i's should disappear. Okay, so the first division is the ugly one, but after this, it's going to get much nicer. So the 1 comes down. 1 times negative 3i, negative 3i. And I add those, and 3i's drop, and we just have negative 1. Negative 1 times negative 3i, positive 3i. And I add, those drop, and we get 1. 1 times negative 3i is negative 3i. Add, and that gives us 0. So the first division is ugly, but the second one gets rid of all the i's. And now it's back to like you would have had before. Remainder, constant, x, and x squared. So we have x squared minus x plus 1. Right. Yeah. Does that one factor nicely?
No.
No. So
That's a
what do we? Quadratic formula. Okay, we can do it. So opposite of b plus or minus square root of b squared minus 4ac all over 2a.
Basically 1 minus 4. I think that's correct.
We did all of that to get another imaginary number.
So we get 1 plus or minus I radical 3 over 2. We know that in imaginaries, I like you to split them up and put it in standard form. As Ryan pointed out earlier, I didn't write one in standard form.
He told you.
He did. All right, my directions for this one were to find all the zeros.
Oh my god. 3i, negative.
So we have these two, we have positive 3i, and we have negative 3i. What was the degree of my original polynomial?
3,
Really?
4.
It was degree 4 because it had next to the 4, so I should have 4 zeros. And I do. 1/2 plus this, 1/2 minus this, positive 3i and negative 3i. Okay, you could also write that as plus and minus 3i. That's okay.
Alright, but you chose the easier way now.
Yeah.
You're starting with the
Well, this isn't that
problem.
bad.
There's always.
It took up half my page.
I had to make a new
There's-
page.
there's always an easy way.
Yeah, maybe not.
I'm gonna figure it out in my next math class.
Okay. All right, any questions on this? No. Okay, let's try another one. We need the practice.
Yeah, Carson's like,
Huh?
Carson's over there, alright.
I'm ready to roll.
Alright. I want to hear Matthew McConaughey, but Carson McConaughey.
All right, what do I do first, guys?
Synthetic
Yeah, I don't.
Synthetic division
Let
with
me
your
look back
negative
to-
2i.
Just like we were doing in the last section.
Oh, you put 3 i's
Negative 2i.
with space. Oh yeah, negative 2i.
And there's going to be a 0 because we're missing.
Right. I have a 1x to the
Oh,
fourth.
2 zeros. Ooh.
I have 0x cubed. I have 3x squared. I have 0x. And I have negative 4.
I like this one.
It's not so bad.
No, this is not bad.
All right. So the 1 comes down. 1 times negative 2i,
Equals positive.
0 plus negative 2i, negative 2i times negative 2i,
4i squared.
which turns into
Negative 4.
3 plus negative 4, negative 1 times negative 2i,
2i
0 plus 2i,
equals positive 4i. Oh wait, sorry.
you're stuck.
It's, yeah, they're positive 4.
Okay, so negative 2i times 2i is negative 4i squared, which is positive 4.
Oh,
That one was much nicer.
I like this.
Look at the difference squares.
Alright, so now what do I do?
Add 2, use the reciprocal with conjugate of
Conjugate.
Yeah.
Conjugate of negative 2i is positive 2i. So we are going to repeat this answer. We're going to divide the answer we just got without the remainder. So the 1, negative 2i, negative 1, and positive 2i. And we know that this time all the i's should go away. So 1 comes down. 1 times 2i, negative 2i plus 2i, 0 times 2i, negative 1 plus 0,
Negative 1.
2i times negative 1,
Negative 2. It's so nice.
so that's my remainder, my constant x and x squared, so I have x squared minus 1,
squares.
difference of squares, that factors into x plus 1, x minus 1. The question asked for all the zeros.
What would the third term be? Like, would we put negative, would it be x minus 2i, or would it be x plus 2i? 'Cause
Oh, if you did the factors,
yeah.
it would be, this one would be x plus 2i.
Oh, so you put both of them?
And this one would be x minus 2i, if you did the factors, yeah. So that's a good point. If I asked for the factored form, you would have x plus 1, x minus 1, x plus 2i, and x minus 2i. If I ask for the zeros, that doesn't include the x's, so what makes x plus 1 0? X minus 1. And then we had the negative 2i and the positive 2i. So again, it was x to the 4th, so we get 4 zeros. The degree tells you how many zeros you get. Is that okay?
Yeah, I'm such a 2 cross with the whole paper.
You guys are complainers today.
I started this because I was like, oh, I won't need to use the next page in this page because it already has stuff on it. I don't.
All right, last example for today.
Okay.
This is something that we will be using more tomorrow. If we have this factored form, we have found the zeros from the factored form before. The only new thing that I'm adding in is I'm asking you multiplicities. So we know that when we find the zeros, what do?
Some equal.
Set each parenthesis equal to 0,
Yeah.
right?
Yeah.
Okay. So I do have a 3x out in front.
Just be 0.
Yeah, if you set that equal to 0, you get 0. So my zeros are 0. If you set 4x minus 5 equal to 0.
5/4.
With the multiplicity of 3.
It's a multiplicity of 3.
Yes. The multiplicity is your exponent. So my exponent is cubed. How do we write multiplicities? Do you guys remember?
M3.
M3. It's just a lowercase m and a 3.
Bro, you should.
Okay.
Might be moving.
X squared plus 3. If I set that equal to
Boogie
0.
line
I
will
don't
like
like that.
Negative
Subtracting 3.
I squared
This just made it so much difficult.
no plus or minus I squared root of 3.
Yeah, so this is.
Yeah.
So x equals plus and minus I radical 3. You can write those together if you prefer to separate it, that's okay.
Multiplicity of 5.
Each of those has a multiplicity of 5.
Wow.
Because we had a 5th power. Questions on that?
Going back to the stuff that we did before this, if the second, like, if the first 2i did all that and then the second 2i didn't work, would it not be 0?
You will never have a case where the first one works and the second one doesn't. It's a guaranteed thing. Any other questions?
Well, it would be like to figure out if this, like, imaginary factor is a 0.
I could, and so basically then you just do the synthetic and see if you
It
get
is
0 for your remainder.
Okay.
All right, there is a handout posted on Classroom for you guys to try.